Hey, Celia, thank you for coming in. Incredible background from your upbringing, which is very STEM focused, to all of these different accomplishments you've done and engagements and at the federal level and working in so many different arenas, but all in really producing economic growth, um, market growth in different ways, partnerships, putting them together, just a multidisciplinary, interdisciplinaries. You cover it, government and industry and academia, you name it, you're involved in some way, but at the top tier. So I really appreciate you coming in and sharing your insights with my audience.
Thank you, Stephen. It's great to be with you today. I look forward to our conversation.
Well, Celia, again, a remarkable history, all this amazing accomplishment, just simply outstanding. So I just want to figure out what created this wonderful person, this amazing career that you have. And, what were those inflection points in your life? Let's say three, and it could have been when you were 3 or 5 years old. It could have been inside, outside the family. It could be mentors, schooling, could have been challenges that you had to overcome. When you look back, what are those three things that, really inspired you to who you are today and continues to inspire you?
I think I've had a career that was not planned, and I often have the opportunity to meet with young people who are at the beginning of their career, and they feel like there's sort of one right answer they have to discover, but really that's not the case. There are so many right answers, and I started out definitely as a scientist. I grew up in a household. My father was a quantum physicist. So I was fortunate in some ways. I think it's in my DNA, perhaps, and a lot of opportunities to interact and be surrounded by people who were in research. He was a professor, so I grew up in a university sort of environment. And while some people are very proud that they're the first person in their family to go to college or to get an advanced degree, it was almost expected for me. And so I would have been a big disappointment if I hadn't gone on and gotten an advanced degree. I started out in science in what I refer to as earth materials. So I actually have my degrees in geology and mineralogy, very much interested in laboratory research in that field. And after I graduated with my PhD, I very quickly pivoted to man-made materials. So similar tools used to do the experimental work and the characterization, various spectroscopies. But the questions that were being asked and answered were quite different. Instead of nature making the sample and you're trying to understand it, you're really driving towards something that can meet certain requirements or the interest of a customer. And I came to the Washington area to do research for the Navy in materials. And I was, enjoying that very much. And as the science moved to smaller and smaller length scales, and I was working on materials that were not structured in the long range. And so being able to look at them at the atomic scale with various tools was enabling. And so what I realized was that I was essentially doing nanoscience research at that point. And an opportunity came up. Nano wasn't really a thing, but then all of a sudden it was. And so there was in the early 2000s a new national nanotechnology initiative, and I was recruited because I was a government scientist to come to the White House Office of Science and Technology Policy and help to establish the multi-agency, multidisciplinary field of nanoscience and nanotechnology research in the US government. It was a very sort of exciting opportunity. And so that I pivoted from, you're talking about inflections, from being sort of really a traditional scientist to being a science policy person and working in an environment where I got to see all the different parts of the science enterprise, because agencies in the US government were investing in university research. They were funding their own government laboratory work. There was this expectation that the results of all of that was going to be very practical. And today we hear about nanoparticles in nanomedicines and all kinds of different nanotechnologies. Sometimes I think people feel like that National Nanotechnology Initiative kind of went through its course and now it's gone. But in fact, it's having enormous impact and continues to. There may not be a nano stock index, but that's because it's really embedded in everything. So after I had been 5 years working in OSTP, I left that and left government at that point and went to an organization that was an industry consortium of the semiconductor industry called the Semiconductor Research Corporation, or SRC. And so I transitioned at that point from government and policy to an industry association. And it's an amazing industry in many ways. We're still, watching it develop and evolve. And there are certain characteristics of the semiconductor industry that are special, if not unique. They have a Moore's law. They all are using the same technology. The silicon transistor is the basis for all consumer electronics. There are other kinds of semiconductor devices, of course, but the huge market is in silicon-based transistor technology. And all of the companies kind of need all the other parts of the ecosystem to be working together. So the design companies, the companies that make the equipment, the companies that are actually making transistors and processors, and all of those need to be working together in a sense. And so the semiconductor industry has a strong history of establishing consortia to make sure that there's coordination going on among the different stakeholders. The organization I was part of was interesting because it actually pulled resources from the semiconductor companies into the consortium, which invested it in fundamental university research. And that led to commonly owned intellectual property that everybody could use and take advantage of. But more importantly, it generated people who had been doing work in their university careers in an area that was relevant to the industry. And so that was a model I had in mind when I got recruited to come and start QED-C, the organization that I lead now, Quantum Economic Development Consortium. It was actually called for by the 2018 National Quantum Initiative Act. So Congress recognized even in 2018 that they were about to spend a lot of money, make some big investments in government-funded research at universities, at laboratories, and so on. At the same time, there were already headlines by big tech companies saying, we're building a quantum computer. Stay tuned, coming soon. And so the government people thought, well, we want to have a bridge between whatever. It's not, sometimes as a policymaker, there's a tendency to think of innovation in a very linear way. Basic research is followed by applied research, is followed by development work, and then prototyping and demonstrations, and eventually a product. And that's a very sort of one-dimensional path. But as quantum is showing, we have people developing products at the same time that there's basic research going on that's relevant and is helping to improve and inform the technology that's being developed by the private sector. And so there really was a need to connect those different activities across that pipeline of innovation. And QED-C is essentially, that's our role. And so we have a member-based organization. It has some 250 members. These are non-government entities. Most of them are companies. They come from suppliers making inputs to quantum systems, lasers, cryogenics, electronics, and so on. There are the system developers or system integrators, not just computers, but sensors and network and communication technologies as well. And there even are end users who are pulling this technology into their domains for certain, solutions to problems, whether it's an oil and gas company, a financial institution, and so on. So QED-C is a very inclusive organization that brings the entire ecosystem together, and not just US-based. I will note about a third of our corporate members are headquartered outside the US. And that was envisioned from the beginning. It's interesting that a government-initiated organization like QED-C was intentionally designed to include stakeholders from outside the US because it's a very global, multinational ecosystem. There are smart people all around the world. There is innovation happening all around the world. We have a white list of countries from which we accept members. So it's not everyone, but we recognize that there needs to be partnerships across borders and both for people and ideas and capital and so on. So that's kind of my trajectory from scientist to policy to industry consortium environments. And it's been very exciting. And as I said, I couldn't have predicted it when I started my career.
Okay, so I'm going to mine a little bit of that history that you gave. So your father was a physicist, in fact, a quantum physicist, and I believe your mother taught math as well, right? So definitely schooled in sort of the hard aspects of science, right? And so that informs you with your really strong interest in science and technology and engineering and things like that. And so that means that those are the courses you were taking. Those are the things that you were really keen on. That's what I am assuming. And then, as you mentioned, you got an undergraduate degree in geological sciences from Brown University. And then you completed a master's and PhD in geochemistry and mineralogy from Penn State. Penn State. And then you went to the U.S. National Research Laboratory, and you've got patents there, technical publications. You did optical material research, new material research, even things like long duration infrared emitting material, right? So I think that's really interesting. And then you went into the White House Office of Science and Technology Policy, where you were one of the leaders in the direction of technology and research and development, and also served as the executive director of the President's Council of Advisors on Science and Technology, so multiple official roles and coordination of the U.S. National Nanotechnology Initiative during that period too. So all of this kind of way spans quantum in some aspects, right? And then moved into this consortium role at Semiconductor Research Corporation, vice president of innovative partnerships. And again, it spans things like materials and manufacturing, and you're either the National Academy of Sciences, Engineering and Medicine, and National Materials and Manufacturing Board. So there's a lot of different components to that. You're interfacing with all of these different prominent areas as well, and sort of cutting your teeth and really becoming expert and bringing communities together, but founded on your deep research early years, and even in things like patents and publications. And then now, you also had a role as Director of Strategic Institutional Planning at Oak Ridge National Laboratory. Interestingly, at the national laboratories in the U.S., some of them, like Oak Ridge, have high-performance computing. In fact, they have an exascale high-performance computer. They also embed quantum and hybrid systems, and they even have this ability to integrate AI. So this kind of combination of quantum, high-performance computing, and AI, and that hybrid is really the present reality of quantum. It's not quantum by itself, but it's really mixed with other kind of capabilities. And Oak Ridge is really one of the leading centers in doing that. So that's a big part of your profile. And then joining SRI International and this QED-C built out at SRI, and now executive director for 2021 onwards, and really bringing together all of these different members, whether you're spreading industry, academia, or government, but not just U.S. based. It's really global, and because there's a lot of opportunity when you work together, right? And as you mentioned, quantum is not just quantum. It's quantum. There's information science. I mean, it spans all these different elements of quantum, right? From sensing and communications, and then there's the computational aspect. So this whole spectrum of technology that's out there. So that's a remarkable background. Now, did I get something wrong in trying to summarize what you just told me?
No, you filled in a few more blanks than I did. And I hope we have a chance to talk a little bit more, of course, about QED-C because it's been around now for a number of years. It has this mission to enable and grow the quantum economy, basically. It's very much driven by industry, but couples into the government-funded research programs. And it's having a moment in a way. It happens to be emerging in the environment that we're in now. And there's geopolitics, there's all the sort of surrounding environment that it has to sort of that it's influenced by. And sometimes it's tempting, I see this a lot in policy world, especially to sort of reach back in the toolbox and say, well, when this technology was emerging, we used this kind of approach and that worked really well. And that's great. It's lessons learned and you can take advantage of that. But often that was a different time. The semiconductor industry emerged, in the 70s and earlier, and then grew, of course, over the decades that followed. And we're now in this situation where the manufacture is very sort of localized in some key areas, and that has certain implications. And I get asked often, what do we need to do with quantum so that we don't end up in a problem situation 20 or 30 years from now? And that's a good question to ask. It's not an easy one to answer. And so I hope we can dig in a little bit on the quantum supply chain, the quantum sort of ecosystem writ large. What are some of the challenges? What are some of the opportunities? But you did a great job.
Okay, and we definitely will. And Celia, thank you for the ability to stay more than an hour, let's say, so we can go beyond the scheduled time because it's such an important area. And in fact, some people believe that the impact of quantum will be bigger than even AI, right? The implications of it. Uh, I recall going back, and we discussed it just prior to us going on camera, where I was invited by a group of 100 CEOs. They're officially called the Financial Services Roundtable, and they're represented by almost 100 trillion in assets under management. They want me to look or bring them a vision of where things they needed to invest in, let's say 10, 15 years into the future. And I mentioned quantum. I said, it's something you're going to definitely have to look at. And I indicated NIST was already inviting applications of algorithms. So for quantum QED, where quantum could sort of break encryption and submissions of algorithms to protect systems and things like that. And I recall at that time the feedback was they thought it was like 100 years out, or 50 years out from 2015. Now, what's your view of that? Is it 50 years out? Is it 10 years out? What's the reality? And you mentioned earlier that you get these hyperscalers who come out with their own quantum systems, like Google in 2019 with their Sycamore computer, and they actually claimed quantum supremacy at that time, right? Though IBM came out later and said, well, you can use high performance computing and we could do similar things. It may take a little bit longer. And so there's been sort of this kind of race, right? Where quantum would come out, and then high performance computing will say, well, we can match that in some way. But it seems like we crossed this point where quantum is not considered, wow, this is real, and it's not 2100. It's maybe 2032 or 2030 in some aspects. Maybe quantum utility, some aspects of quantum advantage will appear around 2030, maybe even before. So what's your view on this? Or what's the view of QED-C on this? Because you play such an important role.
Well, I often say one of the most frequently asked questions is, what is it going to be good for? And then when am I going to have it? So I don't have precise answers for either of those questions. But to your point, the question about when is it going to be here, it depends on your definition of what it is that you're reaching. So you used, a number of terms in your question, like utility scale or, capable of breaking encryption, what they call cryptographically relevant quantum computing. That is a quantum computer that could run Shor's algorithm to factor large numbers and thereby break many of the currently used encryption schemes. That's been understood for quite a long time. Shor's algorithm was published in the mid-90s. And so that's, in a sense, it's a good news story because there was a government-led program to identify and test new algorithms. And then about 2 years ago, almost announced the approved post-quantum cryptographic standards that everybody is encouraged to migrate to. We've done this before. We've had to upgrade the cryptographic standards. It takes a while. It takes resources. Some of the systems are legacy and harder to upgrade. Some of them are embedded, harder to upgrade. So it's not just a trivial like, oh, when I get my, reboot or, install now, I'm all set. So we're in the process of upgrading to new cryptographic standards. And the Q in post-quantum cryptographic, or PQC, doesn't stand for a quantum technology, and it's not running on a quantum computer. So it's a little misleading to think of it as quantum because it's really addressing the threat posed by quantum computing. But it's an important concept, and it sometimes is a first conversation with some of the end users. You mentioned financial institutions, people who protect medical, personal information, things like that. They have information that needs to be secured, and not only is it at risk of being, tapped into and decrypted at some point in the future by a cryptographically relevant quantum computer, it could also be stolen today, stored and decrypted later. And that's this sort of harvest now, decrypt later that you hear about. And so it really is important for those organizations that are responsible for the security of various information to move quickly to upgrade their security systems, their encryption systems. So to the question of timeline, it was thought to be quite a distance in the future before we would have such a powerful computer. Now, whether you would be able to do something useful with a less powerful computer, that was an open question. And to some extent, it still is, although we're seeing more and more evidence that we're getting very close to being able to do some useful things, whether it's modeling and simulation of materials or certain kind of optimization problems and so on, machine learning perhaps. And there's a couple of factors here. One is the associated technology is also moving forward. And so if you're doing a hybrid system and you're coupling quantum in with some existing high performance computing capability, well, that high performance computer is getting more and more capable. And so it's sort of a moving target where quantum is going to add value or whether it's not. And another aspect is the idea that there are other elements, not just making more and more qubits and connecting them to each other, but the problem of error correction, because these are inherently noisy, that's making progress. And that's part of the reason that you're seeing these announcements by some of the big players that tend to shorten the timeline. And I think that's only going to continue. So whereas based on what we know now, you might say it's going to be likely 10 years before we have something that's sufficiently powerful to factor large numbers. But there may be some advances made that would pull that in even shorter. And so it's like the timelines just keep getting shorter and shorter, or the progress is accelerating. And I hear that from others. This is not just, my observation. People who are in the business say, if you had asked me 5 years ago how long it would have taken, I would have said maybe 15. Now I'm saying more like 5 or 10, to get to the same point. And so there's a kind of shrinkage of the timelines that's happening. Another point is that this is being developed all over the world. And there are adversaries. China in particular has identified quantum computing as one of the priorities in their latest 5-year plan, for instance. I think whether it's the US or China or someone else, if they were to have the capability to run Shor's algorithm and thereby decrypt information, they might not make that known publicly. And so that's another question mark is, when will we have this? Well, sooner, later, we don't know. It really depends on where the system is developed. There's obviously a large commercial sector that's working hard to come up with systems that can do something useful from a commercial standpoint. So that's what's publicly visible, and a lot of excitement. I will mention also the DARPA Quantum Benchmarking Initiative is a U.S. government funded program that is evaluating a number of different platforms. And it's interesting to watch the progression of the participants in that program as they move from the first stage to the second stage and so on, suggesting that that program gave a sort of deadline or a target year of 2032 or 33, I believe. So the idea that you would have something that could do something useful by that time frame, it appears that several companies are on track to reach that capability. We're still at the point where there are many different types of transistor or qubit being researched and developed. So it's still early days in one sense, but there's also quite rapid progress being made.
I mean, you brought up DARPA. So DARPA had an earlier program where two companies are now in the final stages, Microsoft and PsiQuantum. So they're in the validation stage to prove by 2033 for utility scale, some kind of utility capability. And then DARPA launched a second initiative, and there was a number of companies that advanced in that second initiative, including Xanadu out of Canada, for example. There's a few out of Canada, but Quantinuum is on there, IBM, and a number of others, which is quite exciting. And so there's that aspect. So that you have this very futuristic research agency, in essence, the DARPA, which is funding these programs, and it looks like some will achieve it by 2033. But if you look at the vendors, some of them are saying we'll have error correction with fault tolerance and utility scale, utility meaning something useful that a classical computer can't do. And they'll have that done maybe by 2029, 2030, and there are a number of companies are claiming that. So it'll be interesting to see how that will manifest itself. So that's really quite fascinating. And because of where you sit, then you're plugged into all of that. You in essence are a piece of that. In fact, you're helping to make that happen as well because of this integration capability you have. And then you earlier talked about post-quantum cryptography, which is really things that you could put on classical systems to protect the data, the communications, things like that, so that you don't get broken by, as you mentioned, QED, when quantum has the ability to break encryption. And you also mentioned that there could be people doing something called harvest and decrypt. In other words, harvesting data and keeping it so they can decrypt it later. And in fact, that's been happening for at least probably 15 years anyways, right? As soon as this idea that quantum would have this capability. So, and then there's this also this concept of Moscow's theorem. Have you looked at Moscow's theorem at all, or have you followed any of his work at the University of Waterloo? Can you talk about Moscow?
Well, I can't do justice to his work. I think you may have talked to him, and people should go and look at some of his online presentations. But he's a deep expert in cybersecurity and is able to, I think, very clearly articulate both the threat and the important, need to take action towards solutions and to mitigate the risk. Cybersecurity is complicated. It is a cost for everybody, right? I mean, every company has an IT person, and they're responsible for making sure systems are secure. And so those, I call them the long-suffering CISO at every company, needs to understand what Michaela Mosca and others are, I think, expert in and are saying. And so I think the world of Michaela. He's a real asset to the community, and a champion and a spokesperson for making sure that the security side is not ignored. And as I said, I think it's a good news story. We have solutions, but they need to be implemented.
Do you have a sense of how long that it would take to implement those solutions? Because really, you would have to do an inventory of everything where you're vulnerable, and your supply chain. You have to consider your supply chain. Yet at the cloud and cloud providers, and it's just not one piece. It's a very complicated puzzle, and takes time. And how about different elements of the federal government in the U.S.? Have you set some timelines of where you're really mandating, certain or at least federal agencies to cut over to post-quantum cryptography enabled capabilities, et cetera?
Yeah, I think there have been some both legislative action taken. Congress has weighed in and said, agencies should do this. There have been executive orders going back a number of years already that give guidance to the different parts of government to tell them to do exactly what you're saying. First, you have to do the inventory and then prioritize which of your systems and which data need to be protected first so that you can, kind of do it in a triage kind of managed way. I have talked to companies who are in the business of providing cybersecurity as a service in a way, or they're in the business of helping companies to maintain security, to be compliant if they have certain requirements that they are imposed on them, maybe by a customer, a government customer, or another customer, and so on. And they have indicated that when they go in to look at these systems and try to do that inventory and assess what's the starting point here, they have been surprised at how large and complex those systems are, even in not very big organizations. And so it's, I think, turned out to be a really significant effort that's needed, and that takes resources, time, people, and money at the end of the day. And so I know that the government agencies are going along that path. And hopefully, the ones that have the most sensitive information are moving quickly to make sure that those systems are updated. One other conversation that I had, which I guess in my mind, I was thinking of upgrading standards, cryptographic standards, as a sort of a patch, a software update primarily. But it was pointed out to me that in some cases, this is very much at the hardware level, embedded in perhaps, a big military system, for instance. It's not just a software update, but it might require hardware upgrades as well. And then that's a much more difficult, time-consuming, costly process. And so it's non-trivial in some cases to update to the new standards for various reasons.
Yeah, and again, you got to look at the different standards organizations, but you already mentioned NIST, right? And NIST has already come out. It was August of 2024. They came out with a series of standards that you can employ. They're open source, basically. They're freely available that you could start implementing. But let's say a company wanted to do an analysis of an inventory. Can they go to the QED-C website, or do you have a classification of providers of those kinds of services so that they can say, so it's like a one-stop shop for the companies that are out there are on this journey and they want to start? I mean, do you provide advisory services in this, or can you point to advisory services through your consortium?
Well, it's not a simple answer in a way. On the one hand, I am not a concierge, and I cannot sort of help individual members necessarily navigate these systems. I just don't have the bandwidth myself, or the QED-C doesn't. But if one company is asking about it, probably many of the companies in QED-C have similar concerns and issues. And so we do try to give resources, information to the members. It's a benefit of membership. We have a program for our members called Quantum Business Edge, which is to give the small and mid-sized companies, especially, the tools to be successful. And whether it's understanding the sort of regulations with regard to cybersecurity or other aspects of their business, how to do marketing, how to hire non-citizens, et cetera. There's all kinds of things that someone who maybe has a PhD in physics and didn't learn that in school is trying to struggle through. And we want to make all of that, work well and to prevent missteps along the way. And so we do provide some resources to our members. Being a member of QED-C alone just puts you in a community. And I spend a lot of time saying, well, here's someone you should talk to. So I definitely try to connect people who have solutions to those who are looking for answers. Over time, I think we may be able to provide some more broad resources and access to information. I'm not endorsing any one solution is another thing. We have a diverse membership. A lot of competitors are members of my consortium. And so I can't pick winners in a sense. I can just say, go talk to these people. They might be able to help you, for instance.
So let's say I become a member, I'm a company, I become a member of this consortium. I can do a search though, within that consortium to look at suppliers or people who have different kinds of expertise, and then I can use my own team to vet who I wanted to contact and things like that.
Absolutely. And we have committees and working groups in the consortium where like-minded people come together to identify challenges and help to solve them. We do, on our public website, list all of our members. And so anyone can actually see. It's a benefit of membership to be, showcased and spotlighted on QED-C's website, of course. We have links for each member to their website where you can learn more. So a company that is admitted to QED-C has done more than just write a check. They have actually been reviewed. They submit an application, and that gets reviewed and approved by my steering committee, which is sort of my board of directors. And we're interested in making sure that companies are not a shell for some, adversarially controlled organization or something. So we do some due diligence before we admit companies, whether they're a U.S. company or a non-U.S. company. So there's a sense of confidence when you're collaborating or partnering with a QED-C member.
So really, QED-C is a great resource for the world, for the enablement of quantum, for the security aspects of quantum. And quantum is not just computational sensing. There's all these different aspects of quantum. And QED-C is really a central hub for all of this as well, right? And have you just released a recent report, for example?
We did. So we have sort of three goals that we focus on. One is making sure the members, have what they need, empowering the members, engaging the members. We are a member organization. Number two is being what we think of as the trusted voice for the quantum industry. And one of the ways that we do that is by doing an annual report on the state of the global quantum economy or quantum industry. And we started doing this because there was some, as you got outside away from the quantum bubble, you maybe thought, well, this is coming, but it's going to be way in the future. I'll keep an eye on it, but it's not going to impact me. Or, maybe you're a policymaker and you think, yeah, it's all, happening at universities and that's all that's going on right now. And so there are a lot of misconceptions, and we wanted to communicate this is an industry. There are people, there are jobs, there are businesses, there are products, and So we did last year for the first time a State of the Global Quantum Industry report where we thought quite long and hard about how do you measure an economy. Well, there's companies. You can track how many companies there are. You can look at the number of jobs and workers. You can look at inputs in the sense of investments, whether those are by governments or by venture or other private investors. And then at the end of the day, it's about revenues. So we have an overview of the quantum ecosystem that this year, for the second year in a row, we released just a couple weeks ago now on World Quantum Day, which is April 14th. Now we have 2 points, so we can look at trends, start looking at trends on the size of the companies, the number of workers, the dollars being invested, and the revenues. And we have actually done a survey-based revenue assessment for the quantum computing part of the quantum ecosystem for several years now. I think this was the 6th year. And we ask every year, what were your revenues this year and what do you think they'll be in the next couple of years? And we're able to see the trends, and the quantum computing revenues have grown between 25 and 30% every year since we started this survey. Now, that doesn't mean that the companies are necessarily profitable. They're probably spending more than they're bringing in revenue, but that's going to eventually cross over. And it's very steady. And one of the things that's interesting is the answer to the question, what do you think your revenues will be next year, is always an underestimate of the actual number that we get the following year. So even the people who know it best are under sort of predicting the growth of this particular sector. We also have done a similar survey-based assessment of the quantum sensing market that we have just done for 2 years now. It's growing at a similar pace. In some ways, there are sensors that are commercially available today. There are others that are still in the sort of concept stage. So it's a fairly diverse sector, but and it's about 1/3 the size of the quantum computing sector right now, and which is partly why there's so much interest in quantum computing. It's a bigger total addressable market in the long term, probably, and has just so many applications, whereas individual sensors tend to have more specific applications. And for an investor, maybe that's, a different kind of bet, if you will. But I encourage folks to go to the QED-C website under our publications page. You can see the this year's report there and see the growth that's happening in all these metrics. It's very positive.
Is there sort of, I guess people can then go to the report and then do some additional analysis because you're compiling a lot of information, and then that further analysis, they could probably look at, what's the state of neutral atoms versus, ion versus, all the different kinds of optical, where is this all going, and because they would all be represented, right? Within, and can you talk about maybe then quickly sort of the major schools of quantum that are out there, or at least some of the prominent ones anyways?
Well, yeah, you mentioned them nicely there. There are a number of different if you want to use sort of a physics term, 2-level systems that define a qubit, and some of them are faster switches, if you will, qubit switches. Some of them are less error prone, perhaps. So there's pros and cons to each of them that are fairly fundamental in a way, maybe very difficult to overcome. A switch based on an atom or an ion is a physical thing that's slower. It's always going to be slower, but than an electronic or photonic device. But they do have certain applications or advantages. Every ion is identical, or every atom, as long as it's the same isotope, is identical. So that is why we have really significant investment going on in multiple technology areas, because they do each hold some promise, some advantages. And we could end up with the situation where we have more than one qubit transistor type computer for different purposes. So it's still kind of, mile 2 of the marathon or something. It's really hard to say who's going to be the winner. And uh, so it's just where we are today. And I think one of the pieces of the stack, in addition to the fact that the hardware is progressing and there's a lot of good news coming out of that community, and we're seeing also that error correction schemes are being developed and offering some significant advantages. The third sort of pillar is algorithms and software to run on the systems. And that's a little sort of spikier in a way. All the big companies, and even some of the not so big companies, have quantum algorithm developers who are working on coming up with algorithms to take advantage of what quantum computers have to offer. It's sort of a chicken and egg problem. Quantum computers are not sufficiently capable to do anything useful yet, but they're coming quickly. And so the algorithms are being developed sometimes on quantum simulators and using clever interim platforms to be able to start to come up with the applications beyond Shor's algorithm that are going to do things that are of commercial value. So there's sort of the hardware and the software that needs to be developed.
I mean, the software's quite exciting, right? And for example, I just finished doing a sort of a private advisory to banking executives, and there's actually quite a deep proliferation of algorithms that can be used in a practical sense in the financial services sector. So all of this is just progressing at quite a rapid speed, so that if you were to look back 4 years ago, you would not predict where we are today because it's progressing so fast. I thought what was really interesting is that you indicated, because you've been tracking some of the data, that even the people in the industry are under predicting where we are today. So the audience should look at your latest report, and then can they sign up so that every time something is released, they get a feed, a news feed, or is that?
So the best thing to do is to sign up to receive our newsletter, which you don't have to join the consortium to receive the newsletter. It goes out every 2 weeks, and that's where we would announce any new reports that come out. Some of them are for members only, but they get, announced, and so we kind of use that to show what members get, of course. But most of our reports are maybe first released to members. They get a sort of heads up first, and then eventually made public. So for instance, not only the overview of our annual State of the Quantum Industry report will be released, but around 1st of June, there will be a much deeper dive analysis provided on the quantum computing market and the quantum sensing market. So those are, and we'll announce those in the newsletter. So everyone should sign up to get the newsletter.
Absolutely. So that's a strong recommendation, right? The world should be consuming what your consortium is producing. Now, earlier you talked about the different elements of your work. Do you want to go into in more detail some of those elements?
Absolutely. Thank you. So I mentioned that we have the empower our members. We are the trusted voice of the industry, which is sort of like what a lot of industry associations do. And then the third is to inform policy, because there still is, it's an emerging technology. There's a lot going on with the support of government, and it's a global race. And so we have, through virtue of our diverse membership, the ability to give a very broad industry perspective. And I get questions from policymakers quite regularly asking, well, what does your membership think about this? And it's really a privilege and really a responsibility in my mind for us to provide that industry perspective. Sometimes we put out a white paper or something publicly. Sometimes it's just in response to a question from the government, wanting to know what's the implications of this or that. What are the top issues for your members? I used to work in government, so I kind of understand the perspective that they have. They have a job to do. I think often when there's a change of administration, new people come in and they say, this is not how you would run a business. And they're right. It's not a business, it's government. And so there are different levers, there are different roles, and but they need, and this is where I feel very strongly, they need to be talking to each other. They need to understand each other. And so QED-C is a one-stop shop for anyone really to understand what the quantum industry is thinking. And we're happy to do that. So we have committees within QED-C where the members come together, and what they want out of the association, of course, is to help their business flourish and succeed. And so that means they're looking for suppliers or customers or collaborators or funding, government contracts. These are all conversations that they can have within QED-C. And they get together in these committees and they talk about everything from what are the sort of big impact use cases, and by impact, they probably mean market size, for my technology, whether it's a computer or a sensor or a quantum network. And so we do sort of studies where we ask the question, what are the use cases and applications? Those reports are entirely public. So they are, again, available on the QED-C website under publications. And you'll see reports with titles like quantum computing for logistics and transportation, or quantum sensing for defense, or quantum computing for managing the electric grid. There's just so many different sectors that have very different computation or sensing problems. And so we bring together experts, both from the user community and from the developer community, and do these assessments of use cases and where are they now and how impactful could they be if we were to achieve them. Then, in order for a use case to be realized, there's often enabling technology. You mentioned that earlier. So do we need some new kinds of electronics or cryogenics or lasers or whatever? So these enabling technologies, there may not be quantum, but they're critical to building a quantum system. What are the gaps there? And then we don't have the resources to actually fill the gaps, but we can take that information to a government funder or even to the private investor and say, here's some opportunities that you should be aware of. There are groups that are focused on benchmarking. We haven't talked about that. You did sort of mention that there's sort of a publications and announcements that something has, demonstrated quantum advantage or superiority using quantum versus traditional. These all require benchmarks, ways of comparing different systems. And that is a somewhat fluid situation as well, because again, it's kind of hard to compare apples to apples when you're talking about photon-based systems versus a superconducting qubit system. So some metrics just don't translate among the different platforms. So benchmarks are important, eventually standards. We're not a standards setting organization, but many of our members participate in standards bodies, and we are happy to support that and also help just communicate among the industry, because industry is really who should be at the front of the row when it comes to setting standards. Most standards are going to be impactful to industry and business. And so it's not a government role necessarily to lead in standard setting. You need to get the industry at the table. We have a workforce committee. You can spend all the money in the world as a government on research, but if you don't have people to do the research, you're not going to get very far. So we need quantum skilled workers, whether they're at universities, at government laboratories, or in industry. And we have a committee that's focused on that. What does it mean to be a quantum skilled worker anyhow? And then we have a committee that's focused on policy and law, which made some advice on export controls that was, I think, taken into consideration when the U.S. was thinking about quantum export controls, immigration policy, anything that has a legal aspect that gets covered in the Law and Policy Committee. So we look at a lot of different pieces. It's not just about the quantum systems development, but the whole sort of ecosystem that's going to be important for each company to fulfill its role and help move forward faster.
Yeah, in essence, you're providing a hub where you can get people to aggregate their capabilities and address the different areas that need to be addressed, right? And whether it's the continued use of quantum, or to protect against some of the aspects of the security side of quantum, or different pieces of the supply chain to work together, whether informing policy to encourage or to support quantum development around the world, and different aspects. So such a key role. Have you, do you participate in, I guess you would participate in conferences in your capacity then, um, QED-C?
Absolutely. I'm happy to speak, especially I'm open to opportunities to speak to the end user communities. I was invited, for instance, to go to a meeting of clinical trial companies. It's a whole industry, it turns out. The drug companies hire other people to do the clinical trials, and they have to design the clinical trial. They have to analyze the results. These are all things that are done, computationally. How do you make sure that you're doing a statistically, reliable trial, and how do you analyze the data and get meaningful results from it? And so there are just almost endless communities that are starting to think about quantum and what does quantum computing mean for my organization. We're doing, I don't know when this podcast is going to drop, but in the middle of May, there is a quantum computing for oil and gas workshop that's being held in Houston, where the oil and gas industry is especially has a lot of representation, obviously. And that's an industry which uses high performance computing to analyze seismic data, to look at fluid flow in the, in the ground, in their like transportation, moving oil, as they say, they take oil out of the ground, they move it around, and then they refine it and deliver it. And all of those are processes that could be improved by quantum computation and quantum sensing, but the workshop is going to focus more on the quantum computing. So that's just another sector, a very big one, that is looking at quantum computing and how it's going to impact them in the future.
And clearly it's going to have an impact in healthcare in profound ways, right? And drug discovery, things like that. So because of the molecular capabilities and interaction kind of capabilities, analyzing some of that, the energy levels and so on. So are you embedding more and more in that space as well?
Absolutely. I think that there's a belief by the community that some of the earliest use cases are likely to be in, this is near and dear to my heart as a former materials person, the design of new materials. And new materials could be batteries, it could be drugs, it could be coatings for ships, it could be all kinds of materials that have, you're trying to target specific characteristics, performance, capabilities, whether it's an antigen or antibody or whatever, or a coating or something not biologic. So there's interest in solving all kinds of problems. Some of the sort of really persistent questions, I guess you could say, like, how can we make fertilizer without so much energy being required? This is a very old process. It works pretty well, but it takes a lot of energy. And so there are many, many challenges that just a small improvement even would have enormous economic and environmental implications.
Can you talk about, excuse me, some of the other communities that you're part of? For example, you're a member of the U.S. delegation to the NATO Transatlantic Quantum Community, former U.S. co-chair of the Quad Investors Network. You have some association with the Quantum Center of Excellence, board member of the Nova Nordisk Foundation on Quantum Foundry, the International Advisory Board on Global Research and Development Center for Business by Quantum AI Technologies in Japan, et cetera, the G7 Quantum Working Group. Can you name some of these groups and the ones where you're currently active or plan to be currently active?
Yeah, I think that the opportunities that I've had to participate in these international bodies shows you how global quantum is. And despite the sort of rhetoric maybe that you read in the headlines these days, I think that allied nations recognize that while they would like, as a nation, to be self-sufficient, to not necessarily have to rely on others, that when it comes to quantum, although there's a bit of a green field and everybody is racing to have a leadership position, nobody is really going to be able to do it all by themselves. And so these organizations and alliances like NATO, the OECD is a quantum program going on, the standards bodies, the International Standards Organization, ISO, and IEC, the Electrotechnical Commission or Community. These standards bodies are all putting in place committees and structures to be able to coordinate the international ecosystem or stakeholder groups toward some standards where it makes sense, or to make connections between solution providers and governments in other parts of the world who are partners and allies. It's sort of happening organically in all these different forums, and they each have a different role. The World Economic Forum has a quantum team that's doing some very interesting work, trying to help countries that maybe aren't already on the map to be able to get into this space. So I'm very supportive of these efforts, because I am firmly of the opinion that building walls around small parts of the world or small ecosystems, and you see it even, let me just add a small side note. Here in the US, we see regional and state-based initiatives now popping up all over the place. Should all of it be happening in one part of the country or another? No, they all need to be successful in a way in order to move forward as quickly as possible. So QED-C is a very inclusive organization. Without putting, our sort of thumb on the scale for any one organization, I am always eager to try to help if it helps build the ecosystem as a whole. At the end of the day, I sort of ask myself, is this good for QED-C members? And if the answer is yes, then I do my best to support these international and other sort of multi-stakeholder exercises and initiatives.
This is unscripted, but it just occurred to me, excuse me, I was asked to support the CEO Leadership Alliance back in 2020. It's a nonprofit, and they were looking at talent enablement, and I suggested AI, and then they embraced it. They have a K-12 college corporate sort of enablement across counties and with the state for talent enablement in AI. And then they founded something called the National Talent Collaborative, working with 33 CEO groups around the US. And that's a broader perspective. But even back in 2020, I said, how about quantum? And I think it was thought to maybe be a bit too futuristic, but you really, when you're working on talent, you have to think in advance, right? So, because it takes time to build in all of the mechanisms to have that talent enablement. I'm just kind of real time. If you're interested, I can do an introduction to the chair and the co-founders of the National Talent Collaborative to get the quantum aspect into this space. And these 33 CEO leadership groups are like all of the major CEOs are involved, and they definitely are interested in talent and also to make sure that you get a broad representation in that talent and bringing talent in and building it at the K-12, the college, to have the employers involved, also having government involved as well. So working across all the different, stakeholders in the system. I'm just thinking you'd be perfect to participate in some of their activities. I'm just kind of brainstorming in real time. I'm thinking of the YPO community of 38,000 CEOs They do about 12 trillion in annual revenue. We just had our big conference called Edge, focused primarily in AI, but there's interest in quantum now. And so I think having you somehow come in as a speaker or something, anyways, I can advocate for that. I think getting the word out because of the work you're doing. Now, you did, and again, if I bring something up, like correct me if I got my data or my research wrong, but on June 7th of 2023 and May 7th of 2025, there's you testified for the House Committee on Science, Space, and Technology, right, and focused on U.S. quantum leadership and the National Quantum Initiative. Are you able to share any of the insights from that, or was it sort of a closed?
No, it's all online. Anybody can go and watch the hearing. It's an interesting experience. You sort of prepare for anything. I mean, the members of the committee can ask you anything, and they all have their sort of pet topics. So you kind of wonder, where they're going to go. But the good news is that quantum is bipartisan and generally is supported. So it was a very friendly hearing in a sense. A lot of times the technology is, not their area of expertise for the most part. There's one physicist on the committee, but most of them are not subject matter experts. And so they're interested in understanding how is this going to impact my district, the people who voted for me. And they also are often very interested in the education pipeline, because that's something that they understand. We do need to have that talent pipeline. I'm going back to your comment about the AI talent programs that you've been part of. Quantum is, I meet often students, this happens a little bit less now, but I'll meet a young person who says, oh, I've heard about quantum. It sounds so exciting, but I don't have a PhD in physics. So I guess I'm not qualified. And that is wrong, because there are many different roles that need to be filled. And we did a report, again, available on our public website, where we surveyed the companies at the time, and this was around 2020, but I don't think the results would be different today. And we asked the companies, what roles are you going to be filling in the next few years? And for each role that they identified, we asked them to say what skills they would want that person to have and what degree would be most preferable, perhaps, or ideal. So we had jobs, skills, and degree information, quite a rich data set. And the findings were that most of the jobs didn't say quantum in the title. It would be software engineer or technical sales or something. Most of the skills didn't say quantum. It was sort of laser, engineering or different traditional skills, you could say. Few of them were quantum specific, but not all by any means. And most of the degrees were not PhD. Most of them, an undergraduate or a master's degree would be the ideal preferred degree. Engineering, physics, materials, computer science, and so on. So what really came through was that if you have a traditional degree in one of these disciplines, physics, materials, chemistry, engineering, electrical engineering, computer science and engineering, mathematics, that plus some quantum familiarity, doesn't take a whole lot, makes you eminently qualified for a career in this space. So we've been trying to communicate that to the educators and to the students so that they understand, that there's a breadth of skills and jobs that are open. And increasingly, as things get more and more sort of higher technology readiness and manufacturability increases, and we move towards the actual products, there's more and more need for technician level people who may need only a 2-year degree or a 4-year degree, but a much more general one with a little bit of hands-on experience. So the workforce pipeline is still taking shape. There's a lot of excitement among young people. I can attest to that. Whenever I have a chance to meet with them, I do. And they have so many questions and are so interested in this field. So it takes a while for equilibrium to kind of be met. The supply and demand will sort itself out. I think there's also, and I just want to make this point, because that pipeline, that K through 12 and getting people kind of all the way through to a 4-year degree or beyond takes many years. We want to also make it possible for people to pivot into the field from maybe a mid-career or early career position in science or engineering with, again, maybe just a certification, a little bit of online or, at their local college education to be able to go into the field, which is definitely growing. Again, our State of the Quantum Industry report shows steady increase in the number of jobs, the number of job postings, number of interns, and so on. So by a lot of metrics, the opportunities continue to expand, but there's a very diverse set of skills that are going to be needed.
And it just brings to mind, though, there's open source like Qiskit from IBM. It's freely available. Penny Lane, right? Readily available, but people could start playing with it. When I interviewed Krista Sabor, she used to be the VP of Quantum at Microsoft. Now she's the VP of Quantum Hardware, I believe, at NVIDIA. But she was indicating that Microsoft has a co-pilot where you don't need a degree to start exploring, and you can work on quantum simulators, right? Which sort of give you the behavior of a quantum computer without actually having one. Can we explore that further? Do you know of other kind of venues or areas that people can get engaged and start just let's say they're even a high school student. I'm just thinking also when I talked to Hausi Mueller, who founded the IEEE Quantum Week, he indicated there's courses that you can get for high school, things like that, right? So
yeah, there's a whole sort of smorgasbord available out there. And that's something that our workforce committee has thought about. Maybe we need to have a sort of resource that would point people to the various opportunities that are there. And there's everything from MIT does a lot of online education. So there's some very in-depth technical courses that are available from online university programs. There's a company or a nonprofit called Qubit by Qubit that does some high school all the way sort of very accessible, doesn't take a lot of linear algebra knowledge to get started. I think they have, again, a range of levels of programming that's available. It's, I think, entirely virtual. I just was visiting last week out in the Bay Area and heard a presentation by a professor of electrical engineering from San Jose State University. They've put together a 4-class sort of certification program that is really, because of where they're located in the heart of Silicon Valley, somebody who's in an existing role at a company there could take these courses and equip themselves to understand quantum, whether it's for their company or to open up other opportunities. So there's sort of everything, and there's these regional initiatives. There's one that's based in the sort of Denver Boulder area called Elevate Quantum. There's one in Chicago, the Chicago Quantum Exchange. There's a new one in the Maryland region, the capital of quantum, and there are some others that are being, coming along in other parts of the country, and all of them have workforce development as one of their core activities. And so if you happen to be located in an area which is served by one of these initiatives, there's something probably right in your backyard. So there's just all kinds of opportunities or resources that are available depending on kind of where you are and how far you want to go. Some of the associations like IEEE offer a lot of professional development. And so participating in programs at IEEE is another great resource for the members and others, I think. So there's a ton out there, and you can kind of dabble and decide whether you want to build a whole sort of resume in the area.
yeah, and then there's also the ACM, Association for Computing Machinery. We got quantum kind of areas of content and areas of interest. People can explore the Learning Center. There's been recent tech talks in the area of quantum, and also they could look at podcasts, but there's all sorts of training materials. So as you mentioned, it'd be good to have maybe a central convening. So this idea of maybe taking it back to your workforce where they could, point to some of the resources, right? And so that people have sort of one-stop area. I just want to finish with a couple of areas. Your consortium did receive a special honor from IEEE. Can you talk a little bit about that? And then you yourself, I believe, you got named to this quantum honor as well, right? A Spotlight Quantum 100, and maybe you could talk about that. That wasn't that long ago. And then we'll get to your sort of final thoughts on where you think all of this is going, and recommendations and questions within the audience. So first of all, let's talk about the IEEE honor.
Yeah, well, it was really an honor. I think it was maybe one of the first years that they were giving out an award, and I just am trying to check the name of it. It's the IEEE Quantum uh, Synergy. I don't know if you have it. Distinguished Synergy Award, the Quantum Technical Community Distinguished Synergy Award. It's a mouthful, but it was really for QED-C. So I am just the sort of figurehead here for receiving this award on behalf of the entire consortium. QED-C has a small staff. I mean, we really are very lean, and it's really because of the members who come together and contribute that we have this collective intelligence and ability to really make meaningful contributions. So it was a great honor to receive from a great institution like IEEE an award recognizing the importance of community. And I look forward to being part of a club, a growing club over the years. The Quantum 100 Award was part of the International Year of Quantum. And as part of that, that was a UN sort of sponsored program or activity, you could say. It was really aimed at getting the word out about quantum, making sure that all parts of the UN community, which is the whole world, were aware and engaged and being engaged. And, as many new technologies do, it's kind of emerging from the most developed and well-resourced parts of the world. There's going to be all kinds of interesting applications that are of public good and, sitting in a more industry-centered organization. I do believe that industry is not going to be in the area for very long if there's not a business. So there does have to be sort of a commercial value, but very quickly, when you have something that's demonstrated to be useful, others are going to take it and go, wow, I can use that for this problem over here, whether it's helping farmers or education or, better medicine that doesn't require refrigeration or something, whatever it is, people are going to start taking it and using it. And so it's not a sort of question of if, but when. And going back to the workforce, we need not only educated people to go work for the quantum industry to help develop it, but then very soon thereafter, we need quantum experts in every other kind of organization so that they can be the recipients and they can be the ones who take it and start making it useful in their domain, whether it's a nonprofit or a for-profit type of organization. So that's kind of where I see us right now. I think that was part of the reason that the IEEE gave this award, why the Quantum 100 recognition came to me and for my leadership of QED-C, frankly. And so it's really an honor to be the recipient of these awards and hopefully to represent the entire community.
And you're also a fellow of the American Association for the Advancement of Science, right? So that's quite a special honor as well. I mean, just remarkable what you accomplished and are continuing to accomplish in what is considered one of the most dynamic and promising areas in the world today. And you're instrumental in being a steward of where this is going. So what are some of the great opportunities that you see upcoming in the quantum space?
Well, 2025 was the International Year of quantum, and that really kicks things off. And I'm seeing this acceleration of progress. So 2026, in my mind, is going to include things like quantum and manufacturing, getting the science and technology out of the lab and into practical application. And so it needs to be scalable, manufacturable, and that's going to take a lot of engineering. There's also going to be quantum investment opportunities. The investor community has been a little distracted lately by AI, understandably, but quantum has been making this steady progress. So although a few years ago, the timeline didn't really align very well with the timeline for venture and private investment, it does now. And that community needs to understand what the opportunities are in this space. They don't have a lot of understanding. So that's an opportunity for QED-C to educate, you could say. And I see also ongoing interest at national levels. The European Union is going to put out a quantum act of some sort where they're going to announce investment. The UK just announced an intent to invest £2 billion in quantum computing, and the US is in the process of reauthorizing and renewing the National Quantum Initiative. Korea, Australia, Japan, many other countries are ramping up their national investment, which means there's opportunities for business, for companies to sell into those parts of the world. And there is funding for not just basic research, but more applied development work. So those are things that I'm watching for 2026.
That's really, really exciting and just a multi-stakeholder opportunity for the world. So that is outstanding. Is there one sort of question or additional recommendation you want to leave the audience?
I guess I would challenge all of your listeners to not think that they have to understand quantum physics in order to get into this area. And by get into this area, I mean, whatever your role is, there will be likely implications and impacts that quantum could have. And so if you're a curious person, I encourage you, now is a great time to start paying attention. And as you pointed out, there's so much that's available online, whether you just sign up for the QED-C newsletter as a start. There are other newsletters in this space. There are LinkedIn, pages that keep track of things. I think it's just a very dynamic and exciting area. And just like you don't know what goes on inside your phone, but you use it all the time, I think it's an opportunity. And if you are someone who's later in your career, like some of us are, you may know a person who's at the beginning of their career, encourage them to think about this. I think there's this misconception that everybody has to have a PhD in physics. It's not the case. And so there's really something for everybody. And it's not all decades in the future. It's starting to be real today. And so it's, again, another reason to start sort of learning and tracking. And it's just an exciting space. And I hope I've been able to share a little bit of that with your audience today.
Well, thank you so much. And in fact, I should have added this earlier, but the ACM, we have something called the ACM Turing Award, which is considered the Nobel Prize of Computing Science. And the winners or the awardees who will receive it in June this year are quantum researchers.
There you go. And last year's Nobel Prize was given to a quantum researcher, a team of them. So yeah, it's definitely.
Deborah Martinez and Clark, right?
Uh-huh.
And in fact, Deborah is now at IBM. He's the chief scientist of quantum hardware, but he was also did the work on cat qubits, which is used by Alice and Bob, right? Which is another quantum company. Yep. Martinez has taken this role because he left that advisory role to take on head of quantum hardware or chief scientist of quantum hardware at Google is an opportunity you probably don't want to pass up, right? So,
well, and he's moved on from Google. He's now at a startup called Colab. And
I didn't know that.
Yeah, founded a new company. Still a member of QED-C, I'm proud to say. So it's a small but flourishing community, and it's a very collegial one. So if you are sort of interested in quantum or part of it in some way, shape, or form, whether you're a supplier or an end user, feel free to contact us to learn more about what QED-C has to offer. Thanks for the opportunity to join you today.
Yeah, and in fact, I would recommend the audience to engage with QED-C. I mean, just marvelous work. And Celia, thank you for coming in and sharing all of these deep insights in what's happening in your space, and you being such a dynamic leader in the space as well. So thank you again.
Well, let's do it again in a year and see what's happened in the interim.
Absolutely.
Thank you for listening to the Brand Called You videocast and podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the Brand Called You.